if you tell me it's a bowling ball on a hill, what I hear is it's not zero competency. It actually has, by virtue of least action principles, it actually has a little bit of competency to minimize things like kinetic and the total energy and all that kind of stuff. But I also know that if I want to change the way the ball rolls, I don't have any. I'm going to gain zero benefit by thinking about internal state, internal, how does the ball feel about this landscape? That's not going to be a useful way for me to go. And the only tools I have are to modify the actual landscape. So I can put in bumps or I can push the ball or something, but something like that. It does have a little competency in that I don't have to push it down the hill. It will find its way down. But really all I have is these kind of very low agency ways to interact with it. On the other hand, if you tell me that what you have is a mouse on a hill, now we got a different story, because now I know that, well, the tools I was going to use for that bowling ball, kind of useless. And what I really need to understand is what is the behavioral landscape that the animal is seeing. What are the things that attract it? What are the things that repel or scare it? What are the things that it remembers about having been here before? In other words, when I want to change that system's behavior, I need to do a lot of thinking about what are the internal states of that system and how it sees the landscape. It's not how I see the landscape that matters, it's how the system sees the landscape. And so that tells me different ways that I can interact with it, right? And different way I can change its beliefs. I can various things you can do, and all the way up to humans and so on. So that's the spectrum of cognition that we'll talk about in the TAME framework. So the idea there then is that when you say that the body is intelligent, what you're really saying is, are there ways to interact with that aspect of it? And I really don't make that much of a distinction between brain and body. I think they're very tightly linked. But the question is, do I treat this thing like a dumb clockwork, or am I better off assuming that it has certain autonomous capacities? Does it have memory? Does it have homeostatic properties that I don't need to micromanage, right? The nice thing about your thermostat is that you don't have to push it all day long. You just set the set point and you leave it alone. And so, right, so what do I need to know about this? So that's how I see all kinds of intelligence and agency statements as engineering protocols.
Jeff Hawkins' thousand brains theory.
A little bit. I mean, they're not an expert in it, but
me neither. Yeah, I know this is like the bare bones of it. That, but it reminds me of this quite a bit, because he claims that the brain builds all these different models of the world using reference frames, and so it just I'm not sure if you have any comments about that, or maybe how it might apply to this, or if there's any link at all.
Yeah. I mean, I think it's very interesting and important, and I think that everything is great except instead of the brain, you can put entire body, right? So I think the whole body is doing this. There are not that many things that your brain is doing that the whole body doesn't, that other parts of the body aren't doing in various spaces that are hard for us to access and see. But I think that kind of model is the right way to look at it.
Something about the amount, how there might be nothing in the universe, correct me if I'm wrong, please, but that has like a zero, a degree of zero, I don't know, causal influence or some kind of computation. Could you unpack that a little bit? It's something that you mentioned clearly, that this idea might make people uncomfortable even. Sure. What are some of the possible implications of it?
Yeah. Well, many of these ideas make people uncomfortable. So I'll just barrel on, I guess. So one of the key things about the TAME framework, which really started in that cognitive light cone model, is that we want to be able to have the same. First of all, we want to be able to say that agency, cognition, computation of the type that we're talking about is not binary. Okay, that it's a spectrum, it's a continuum. So we want to be able to define that continuum, and if you're going to and the goal is to define a continuum, and I call it in that paper, I call it a continuum of persuadability, and that's on purpose. Again, it's because the reason is that I'm not talking about I'm not trying to pin it on a kind of a single universal objective fact about the system. I'm looking at it from the perspective of an observer, who wants to relate to it somehow, to understand it, to change how it works, to get it to do something, to manipulate it somehow, to make a new one, whatever. But it's that's why TAME stands for technological approach to mind everywhere. The technological aspect is we're not arguing philosophy here. We are trying to get to very specific and testable ways in which other beings, observers, and they could be scientists like us, they could be biologicals, they could be parasites, they could be conspecifics, it could be the entire evolutionary process. All of those are observers. Are able to optimally interact with that system. So if you have this spectrum, and so for now, on the right side of the spectrum are some humans, let's say, and going down, you see all sorts of things, systems with which you can interact through. So with the humans, you can actually give them reasons, and they will go and do things autonomously, right? And you don't have to micromanage the how or the when or the what. You just give them a reason, and they will pick a goal and sort of run with it. So lots of like huge agency, lots of autonomous activity. And so down past that, you have some other creatures, like certain animals that you can train in various ways. And so you can give them a goal, and they will, with various degrees of ingenuity, they will be able to achieve that goal, and so on. And you can sort of keep going down and down. And so with any, and that's a slide that you could at some point, if you want to do screen sharing, you could show that. But
which slide is that?
Well, it might be figure 1. It might be from the TAME paper. It might be I don't remember at this point, but it might be the one of the first figures on the spectrum of persuadability. And again, it's all about engineering protocols. It's all, if you want to persuade that system to do something, how do you do it? Do you do it the way you would with a mechanical clock, by rewiring the hardware? Do you do it like you would with a thermostat, by changing the set point? Do you do it the way you would with a dog or a horse, by giving it rewards and punishments for specific behaviors? Or do you do it like with a human, by giving them actual cogent reasons for them to do things? So you construct this kind of, and of course, I'm not the first person to try for this kind of spectrum of, Wiener and Rosenbluth and Bigelow did this in like 1943. They tried for one, and before that, William James talked about this kind of thing before that. So the thing about those kinds of spectra is that the natural question is, well, where's the bottom of it? So is there a bottom of it? Yeah. And if there is, I mean, most people assume that there is, and most people put it pretty, to me, quite far up the thing. Actually, people have concerns about plant agency and insects and things like this, which I think is just, I think those are things so far off from where if there is a zero, they're so far off from the zero that it's it's completely wrong. But
wait, do you mean they're so far close to zero?
No. I mean, the zero should be the zero. Yeah. I mean, we have so many things, so many interesting things to worry about that are really minimal compared to that. The plants and other things are like, I mean, to me, of course, they're on the spectrum. But the question is there a zero? And if there is a zero, what does it look like? And so I don't have a super firm conclusion on this, but I tend to think the answer is no, that there is no zero, and I'll tell you why. Let's imagine for a moment, and this is an exercise I recommend to everybody, and anybody who thinks that, well, of course I have it, whatever it is, it's a cognition. I have true agency, whatever that is. I've got it, and definitely this rock here doesn't, or a cell, let's say, doesn't, or an unfertilized oocyte, which all of us were at one point, doesn't. So the exercise that you need to go through is, what is the most minimal version that had it, and what happened right before that? So you've got it, and you sort of roll yourself back to however old you are, and then 9 months back slowly but surely, and guess what? You're an unfertilized oocyte. So at some point, it showed up, and if you really think there's a sharp zero or non-zero, you have to say where it showed up. And of course, developmental biology offers absolutely no place where you can say, that's it right there. That's where it shows. And so that's a problem. And so I suggest to everybody to do this experiment and to say, what is the absolute minimal version of agency that you think it would take to get on the spectrum? And and people will often say, well, it's a cell. And I'll say, yeah, well, what if it's just slightly simpler than a cell? I mean, surely that's fine too. And say, yeah, okay, that's fine. So go all the way to the bottom, figure out what you think is the absolute minimum. So when I think about the absolute minimum, I want it to have two features. The first feature I want it to have, any system that's on that spectrum, the first feature I want it to have is some degree of goal-directed behavior. Goal-directed behavior means that it tends to achieve a particular outcome in some kind of state space. And if it is deviated from that, it will expend some minimal degree of capacity to still get there. Okay. And so that's the first thing, some kind of goal-directed activity. And the second thing, I would expect some minimal degree of indeterminacy. In other words, the behavior of this thing is not well described by knowing exactly what's happening to it right now. In other words, in the local microenvironment, all the pushes and pulls that are happening right now are not perfectly sufficient to explain what's going to happen, meaning that the distance between it and the causes that control it have some depth to it. It's not just something that, however you push it, that's how it acts. There's something else that controls you. You can't derive it from the local environment. Okay. And so this could be memory, it could be predictive capacity that it has, whatever. So as we think about those two minimal things, we realize that even elementary particles have this, because the first part, the goal-directed activity, is taken care of by least action principles in physics. So they have the ability to minimize and maximize certain quantities. I'm no physicist, but somebody like Chris Fields and Carl Friston and so on have a much more sophisticated story about this. I'm telling you a very, very simple version that basically all the way baked in at the very bottom of physics are these variational principles where you can already see that certain systems have non-zero capability to get to the same goal. And again, it's like think of a rock or a roller coaster. If I'm an engineer, the reason that it's not zero, the reason that it isn't is a zero on that spectrum is if I'm an engineer, I have to spend a lot of time working on how I'm going to get this thing up the roller coaster hill, but I don't have to worry about how it gets down. I don't have to push it down. That isn't much compared to the human agents. You say, wow, that's a rock, that's a roller coaster rolling down the thing. I mean, that's minuscule. Like, right, we were looking for the minimal version. We weren't looking for a nice, rich version of agency that humans have or that other animals have. We were looking for the minimum. The minimum is, what can I depend on this thing to do on its own? What preferences does it have on its own? And this is a super old idea. Giordano Bruno used to say stuff like this. This is very old. That it isn't zero. The competency of these things is not zero. It's very low, but it isn't zero. And the thing about the indeterminacy, we have that in the quantum realm too, because we have lots of events that are not directly determined by what happens now. So out of those two ingredients now, you can imagine two ways to go from that. So super minimal, but it would have to be minimal because that's what we start out looking for. Of course, it doesn't look like human agency or even big brain agency, because we started out looking for the minimal versions. So now two things can happen there. One is you can aggregate those things in a very dumb fashion that doesn't increase the depth of it. And that means taking a bunch of particles and making a big rock out of them. When you do that, you have not increased the agency at all beyond that very minimum that the individual particles had. It still has equally the same very minimal. But there are other ways to aggregate them which actually amplify what's going on here. And the systems that do that, that's what we call life. That's what when people, I don't spend a whole lot of time trying to come up with a definition for life, but that's what I think life really refers to. What we call life is any system that is really good at scaling these fundamentally non-zero competencies of chemistry and physics into much larger competencies, larger cognitive light cones, novel problem spaces, and things that we begin to recognize as being on the spectrum. So that's what life is good at, is scaling. And so I once asked Chris if given all of that, I said, is it possible to have a universe with no least action principles? So basically, could we our world doesn't, to me, our world doesn't have zero agency anywhere. But the question is, could there be one? Could there be a universe that had literally zero? And Chris said that the only way to do that is to have a universe where nothing ever happens, a static world where nothing changes. Because I'm not going to go down that rabbit hole here, but he could tell you a whole story about the kind of active inference like process that happens in any interaction between any two things in the world. They don't have to be brains, they don't have to be alive. That minimal interaction between object in the environment and what makes for a permanent object and all these kinds of things, all of that is baked in at the very bottom level of physics. Life is just good at scaling it up.